dann kann ich direkt den ersten Speaker vorstellen, unsere Keynote. Dann auch nochmal vielen Dank ans Programmkomitee, die es geschafft haben, Christoph Kerschbaumer von Mozilla zu gewinnen und hier einen kleinen Einblick zu geben, was dort so passiert und in welche Richtung dort auch die Security weiterentwickelt wird. Herzlich willkommen.
Well, hello, good morning, welcome. Eve, thanks for the gentle introduction. I'm very excited to be here, and I guess we jump right in. So 2/3 of all applications are vulnerable to code injection attacks. Again, 2/3 of all applications are vulnerable to code injection attacks. And when we talk about all applications, then I guess we have to include Firefox in that pool of applications as well. In the next 40 minutes, I would like to take you on a tour and show you what Firefox does to harden the content security landscape within Firefox. This might be not a traditional keynote in a sense that you are familiar with, but I think the techniques that I describe here are very well applicable to the wider pool of applications out there. I guess we all know there is no silver bullet against code injection attacks, against security or for security in general. So what we do, we are hardening the security landscape by adding layers and layers of security. To start with, I want to show you what we do to enforce content security by default. And with that, I mean we would like to make sure that our developers within Firefox cannot shoot themselves in the foot. We have to better support them to build in the security by default, make it harder for them to break it. Let's take a look at what content security checks we are doing. Most and foremost, or what I consider the most important thing is when JavaScript renders in a browser, we make sure that JavaScript cannot access the local file system. This is, in my opinion, the worst case scenario. If you visit a web page and that web page, simply the JavaScript on that page can access my pictures, the contracts I've signed with companies, and see my personal information and potentially upload it to the internet itself. Additionally, we enforce the same origin policy. I hope you have all heard about the same origin policy. But basically, it makes sure that objects originating from one origin cannot be accessed by code coming from a different origin. Additionally, we enforce the mixed content blocker, and on a very high level, if you visit a top page that is delivered over HTTPS, we make sure that content, active content, cannot be loaded through HTTP. We are blocking that mixed content. And for what it's worth for this talk, what I would like to guide you through, the running example is the content security policy. And the content security policy is an added layer of security that mitigates code injection attacks. In a little more detail, let me guide you through the following example. Let's assume you visit a web page that is called good.com. And that web page ships with a CSP of script source good.com. The CSP, for everyone not familiar, I hope no one needs that information, but in case there is still someone in that audience who is new to OWASP and new to application security. The content security policy is basically an allow listing mechanism where a web developer or a web application then can define where sources can be loaded from. So in that case, scriptsourcegood.com, it is basically a signal from the web application to the browser to let the browser know, please load script only coming from good.com. So now we are loading such a script, right? So the script load happens, we're loading some JavaScript, the GET request happens, and at that point, we have to enforce the first security check. At this point, we enforce a variety of security checks, but for the purpose of this talk, let's talk about CSP. So in that case, we would make sure, or Firefox, or every other browser that implements CSP makes sure that the origin of the request matches whatever is allowed listed in the CSP. So now what happens if that browser responds with the redirect? And for what it's worth, this happens quite often, right? Like 1 out of 10, actually a little bit more, of requests hit a server-side redirect, right? And we all know we don't want to end up in an undefined state where we don't know what to do in case of a redirect. So let's go back to the example, and now let's assume for whatever reason we hit a redirect to an evil attacker, right? So we have to enforce additional security checks at the time we come back, the response comes back to the browser. We enforce another security check and make sure that the origin is still allowed listed in the CSP. So in that case, the second security check would block that script from loading and hopefully would keep us safe. So this is, on a very high level, what the content security checks are in terms of what we enforce in Firefox. And now traditionally, when we look back, and I'm pretty sure you have all witnessed that, web applications don't start out with the security built in, right? They grow over time. And in the case of Firefox, I mean, Firefox code base is roughly 15 years old, more or less. And back then, security was not that big of a deal. Sure, we built in security, but it was not with the security we need these days. Also, Firefox only had a few developers compared to nowadays, where we literally have 1,000 people like hacking on our code base, right? So we have to better support our developers and make sure to keep us safe. A little bit of background and terminology. I try to keep that as little as possible, but for the purpose of this talk, it is important to understand a few things that are built in or that we use within Firefox. So you probably have heard of Gecko, and Gecko is the rendering engine, layout engine within Firefox. That makes sure that images and text appears on your screen whenever you visit a web page. And underneath all that, we have the Neko layer. And the Neko layer is responsible for really loading bits over the wire. So now that we know what Gecko and Neko is, let's take another look. And back in the days, a resource load originated in Gecko. And as you can see here, we had opt-in security checks. Now you can imagine that Firefox always had a bunch of very smart developers, but just the model itself, having opt-in security checks, is kind of error-prone by itself. And it would be way better if we could switch that model around. Additionally, if a resource load started, we go down to the Neko layer. And this is also some of the reasons, I mean, this is a lot of legacy code. And back in the days, Firefox or Mozilla wanted to ship Neko as a standalone client. So there was a very clear border between Gecko and Neko. These days, it vanishes a little bit. But what happens here is, if we go down to the Neko layer, and if you think back of the example that I just showed you, if we load something from a web server and that responds with the redirect, well, sometimes we were not even sure what we were loading, right? And this is obviously very bad in terms of CSP when we don't know what directive we should match the load to. For example, if you hit a redirect and then you don't know whether you were loading an image or a script or a CSS file, and then back in the days, we started to add a few hot fixes to actually figure that out. But to sum it up, that model was not sustainable going forward into the next 10 years of good security within Firefox. So we flipped that entire model completely around. And as I mentioned earlier, the border between Gecko and Neko vanished, right? So it kind of melted together. And by doing that, it allowed us to basically provide a load context for every load. Whenever you want to start a load, like really in the constructor, you had to provide a bunch of arguments. And then later in the Neko layer, whenever we started the resource load, we made sure that the security is enforced by default. And by adding that additional load context, which was, by the way, completely frozen at creation time, so that is in an immutable state, also, when we hit the server-side redirect, we can provide the same security guarantees as for the initial security check, which is obviously crucial. So let's take yet a closer look on how that looks like. And I start from the bottom up. So security flags. By default, all security checks are enforced. So basically, if you create some new shiny thing, whatever it is that we need in the web these days, and you create a new channel which is internally used for loading bits over the wire, then you have to explicitly define what security checks not to enforce. And this is a very good mechanism because our developers basically start doing that. Stuff doesn't work. What do? They call the security team. Hey, why is this not working? What can we do to make it work, right? And this is a great model when you think about it, right? It's not that they have to add the security checks, but they have to ask us what to do to make it work. The next thing here is the content policy type. This is, for example, type script, type image, type CSS, whatever you're about to load, XHR requests, whatever it is. Surely at this point, this is kind of, you have to define that yourself as a developer, but there is still a very strong code review process within Firefox and within Mozilla, and still someone of the security team reviews that code before it can be checked into the code base. And then one more thing, we have a principle. And the principle basically represents the security context of what we are about to load. Again, I want to detour shortly on the terminology because we will come back to that later in the talk. The reason why we cannot simply use a URI to reflect the security context, because there is more, right? So for example, you know that Firefox, the backend is written in C++, C, nowadays a little bit of Rust, but all of our front-end code is written in HTML and JavaScript. And that front-end code, like really whatever you see in terms of Firefox UI and UX, that is called Chrome code. So it runs with system privileges, right? And that's why we have that system principle. It reflects the security context of the system itself. We have the content principle, which is basically just the URI wrapped plus some additional parameters. But on very easy terms, it is just a URI of that web page that you're visiting. And then we also have a null principle. And the null principle is needed for sandboxed context or for data URIs, because they don't really have a URI, so we create our own. Worth mentioning here as well is that the null principle is only same origin with itself. So now coming back, and let's take a closer look on what information is encoded in that load info, in that load context that I was talking about earlier. So again, from the bottom up, we have the security flags. We have allow cross-origin, because JavaScript files can be loaded cross-origin. We have the type script, which represents the JavaScript, the script type. And in that case, the triggering principle is https://good.com, basically the URI that triggers or kicks off the load of that JavaScript request, right? And with that, we can enforce, we have all the information bundled within that load context, and with that, we can enforce the security checks by default. I gave a talk about this a while ago, and I found the numbers again on how much effort we put in to build that. And I think it's very critical for this audience, because we talked about that yesterday for a long time. In most systems, the security is not built in, right? We have to retroactively build security into a system, which is obviously hard, right? So for the engineering effort for doing that is we updated 100 plus network loads, right? We updated 400 plus tests to verify that those network loads are working correctly and that our security is enforced correctly. It took us 20 months, one full-time engineer, and since Firefox is organized as modules, we also had to get review from each module owner. For example, when we changed the image loader to make sure we provide that load context, we had to get review from a peer or even the module owner of the image loader. And same for the script loader and for the CSS loader. And now I want to take a step back and give you a minute to breathe and think about how much code did we have to write? How long did it take us? How much effort did we really put in? And when I think about it, I mean, Mozilla is a big organization, right? I mean, a large organization, not as large as some other companies, but still on the greater scale, on the higher end, in my opinion. And for us, it took a lot of convincing. I mean, this is obviously time that we could spend on something else, right? So we have to do a lot of convincing for the higher level management that this is worth doing. At Mozilla, it is maybe a little bit easier because we don't treat the security and privacy of our users as optional, right? So it was, in the end, it was a no-brainer for us to do that. But again, some of those numbers, it was like 518 change sets, roughly 100,000 lines of code that was changed, right? And 3,500 hours, like summing it all together, right? Like this is a lot of money, a big investment, and I understand that. And the reason I emphasize on that so much is because it would be great, obviously this is hard, but it would be great if we could build in security by default from the very beginning. With that, I end the first part, but as I mentioned, we add multiple layers of security because there is no silver bullet, right? We add layers and layers of security. And if the first one is bypassed, we fine-grain and fine-grain until we have so many different layers. I'm pretty sure that in the afternoon, Samuel will tell you very much the same, that is not a single entry point, a single point of failure, but a chaining of problems in a system that basically leads to the worst-case scenario. So moving on to the second part of my talk, is removing and preventing inline script execution. Firefox, you have probably seen that. Firefox ships with a variety of built-in pages, so-called about pages. And those can be seen as full-blown web applications, right? Those are also written in HTML and JavaScript itself. And some of them are what we call content privileged, which is they run with that content principle I talked about earlier. But then we have some that are system privileged. And I'm pretty sure you have seen, hopefully you have fiddled around with about config, or you adapted some of the other parameters in your Firefox to make it more suited to your needs in the end, right? So some of these about pages are accessible from the web, some are not. Then we have, for example, about net error, about cert error, which is basically internal pages that are somehow semi-privileged because they need some information from the browser because the TLS certificate in that case is outdated or for whatever other reason is not working. And those are semi-privileged. So those are all entry points into our code base, right? And we want to make sure that no one can inject code or find an entry point through those about pages, right? So what we did is we looked at it from different angles and we tried to create a threat model for those about pages as well. And as I mentioned earlier, there's a lot of legacy code in the Firefox code base. And not only in Firefox, I'm pretty sure that is in all applications out there whenever you take a closer look. But anyway, in the terms of Firefox, there is a lot of legacy inline script code in those about pages, right? So what we want to do is eliminate all that inline script. So later on, we can add guards that prevent all kinds of inline script execution. So we looked at that, and this, I don't have exact numbers on that, but this is also on the scale a very similar effort to the security by default I mentioned earlier. So by removing all that inline script, this is slightly simplified, right? Because there is all kinds of inline event handlers and all that kind of inline code that we have in our code base. So we managed to remove all of it, and instead we load all from packaged JavaScript files. And when I talk about packaged, it is really like basically simplified, zipped and shipped with the browser, right? So we really load it through the internal Chrome protocol. This was not an easy effort. And now I'm coming back to the principles we talked earlier. Sorry, one thing here is the content security policy is what we use as a guard to make sure that no inline script can be executed. But what's more important here is that in the old days, the CSP used to be placed or hangs off the principal. And that was for a good reason back then. Some insights here is that data URIs used to inherit the security context of the including page. So in that case, since we inherited the principal, the CSP was inherited for free, right? But the model changed, and data URIs have become cross-origin, only the same origin with itself. So we also changed that model here. And the principle, on the left-hand side, we have a one-to-one correlation between the page and the principal, right? This is for content privilege pages. But for system privilege pages, that was different because we used a singleton instance of the system principal. So the system principal was shared for all the system privilege pages. And obviously now you cannot attach or apply a CSP to that system principal because then it wouldn't work, right? So we had to change that entire model and move the CSP away from the principal and what is called the client. And the client reflects the security context for CSP way better. Also in the terms of workers. Workers become more and more important on the web and used widely. So the client just better reflects the security context for the CSP internally. By creating that one-to-one relationship for system privilege pages, we now also can apply a CSP, a very strong CSP, to all of the system privileged about pages. Through that, we removed all the inline script, and now we have guards in place that enforce a very strong CSP on all the roughly 50 about pages, right? And this CSP does not include unsafe inline, which means that inline script cannot be executed, right? By removing all inline script from our code base or from all the about pages, we can apply that CSP, and that also mitigates or provides a very strong first line of defense against code injection attacks, because inline script will just not be executed anymore. Whew, a lot of stuff, right? Let's take a break, and then we move on to the next. As I said, there are layers and layers and layers of security, and I can be up here like for 24 hours and tell you so much about what we do. But I only have 40 minutes, so I provide a snapshot of what we are doing. And this one, the next one, this is the best one. I like that one. That part is the best, in my opinion. And that really applies to all applications as well. Hardening the principal API. And by now we have established what principles are, right? So everyone knows what that is. And for the content principle, it is just a wrapped URI, right? So now what we have seen is the NSI principal API. I mean, it provides more than that. But the crucial thing here that I want to show you is that we have a read-only attribute URI to get the URI out of the principal. Okay? The principal should be used for security questions, right? But what we have seen is, for a variety of reasons, and again, this is not blaming anyone. This is just how things grow. This is very natural, and that happens in all applications, right? So what happens here is that 200 call sites just query the URI of the principal, And they all do their own little interpretation of security. This is just a few simplified examples, right? But for example, the first one gets the URI of the principal and then checks, oh, I know there is HTTPS, so I do something special for HTTPS. There is HTTP, I do yet something special, and then there is everything else, right? Additionally, someone else cares about data URIs. Oh yeah, there are data URIs, there are blob, and everything else. And additionally, if someone has a typo, again, there are a lot of smart people working at Mozilla, and we do a load of code review. So we haven't really identified the third case, but it is technically very likely possibly, right? That someone just has a typo, there is whatever deadline we have to meet, and that code gets checked in, right? So that model by itself is obviously not sustainable, very error prone, and we as security team should not put that burden on our developers. We should better support them and make their life easier as good as possible, right? So we should simplify that API, not providing or exposing things that leave a lot of room for interpretation by the developer, right? It would be way better if we changed the API so that our developers can ask the principal questions and get a Boolean answer, right? And this is exactly what we did. There is a lot of those cases, right? I simplified that because what I really wanted to show is just don't expose things that leave room for interpretation, but make it short, precise, and infallible, right? So here we have a read-only Boolean is secure. And with that, the real security code is encapsulated within the principle itself, right? We know that we have to take care about HTTPS, HTTP, data URIs, blob URIs, whatever there is and there isn't, right? It's one central point, and everywhere in the code base, we have the same security checks because it's one check, right? So this is also something, hopefully I can bring that across to keep that in mind for everyone. Have small APIs, precise APIs, don't expose things and leave room for interpretation. Mostly to better support your team. I mean, I understand that not every small company has like a big security team, but I'm pretty sure we can get the low-hanging fruit out of the way. And that, I'm pretty sure, keeps us safe in most of the cases. And as you can see, we're moving fast here. We are already on the top. The wall is so big. And we are really getting down to the very small, fine things that we do within Firefox, right? And the next thing what we do here is monitoring DOM access. In a simplified world, whenever you visit a web page, that web page loads content from info.com and from content.com and whatever benign source that the web page pulls in, and it creates some kind of DOM. This is the DOM structure. That should represent the DOM structure. But then it's also possible that there is some attacker that manages to be on that web page, right? And that attacker can do a variety of things, right? Like either it can add a DOM node, or it can traverse the entire DOM and try to exfiltrate some data of the DOM, like your credit card numbers or whatever it is. But whatever the attacker wants, like everything that is worth going for, needs some interaction with the DOM, right? And what we think is, or at least for our internal use, again, we are probably in a very unique position, like Firefox is in a unique position that we provide applications and have control over the full browser in addition, right? So we can do very special things that other web applications can't do. But we want to make sure that our applications are secure, and since we have access to all of it, we want to make use of it. And for our own applications, we think that the current security model is too coarse, right? So the same origin policy doesn't do anything if a script is loaded in the same execution context, right? Because it appears from a security point of view as if it were loaded from the same origin as the top-level page. iframe sandboxing doesn't do anything here. And also the content security policy doesn't do anything if we load information in the same security context. On a very high-level, simplified world, we have the JavaScript engine, because your malicious JavaScript code needs to execute, right? And on the other hand, we have the DOM. And every interaction between the JavaScript engine and the DOM needs to go through those DOM bindings, right? So we thought, well, why can't we add an additional monitoring system or auditing system in those DOM bindings, right? And maybe we can even assure that outdated or considered insecure artifacts of the JavaScript language cannot be checked into our code base by our own application developers, right? So those DOM bindings, there are a variety of things how you can set attributes in a web page, right? I only list a few here. I'm pretty sure there are way more. But what's important is that all of these codes, or all of these calls in our code base boil down to set attribute, right? And within that set attribute, we added our auditing and monitoring system, right? And through that, we can do a variety of very cool and exciting things. So what we have done is we eliminated all of eval from our code base. Again, back in the days, I'm pretty sure, it predates my time at Mozilla, but I'm pretty sure we did this because we were able to develop faster. We had a smaller engineering force, right? So everything that allows you to go faster is obviously crucial for a smaller team. The bigger you get, and especially the more emphasis you put on security, the more crucial it is to eliminate all of those insecure constructs. So what we did for eval, for example, right? First of all, we added a new assertion, and this is what I suggest everyone. Add an assertion to make sure that no occurrences of whatever you consider unsecure gets added. Because otherwise you start rewriting code, and at the same time, people fill up your queue with more work for you. If you add an assertion and prevent that new occurrences, in that case of eval, can be added, then that shrinks your amount of work that you have to do. There were still like 50 plus occurrences of eval, even in system privileged context land, right? So one can imagine if someone manages to bypass all of our security mechanisms and manages to use the DOM to somehow hide some information that then gets evaled in system privilege context, this is like really game over, right? So this all takes time. And we started by eliminating everything in system privilege context, then on all of our about pages. And then slowly we rolled that out to our user base as well, right? Because there are a lot of customized files that people are allowed to load in Firefox. And some of them, like using our telemetry system, which reports back information to Firefox or to Mozilla, we learned that people also put eval in files they load themselves, right? And by learning all these things, we can shrink the scope and make it very tight and enforce, like allow listing some of those things that we know are safe because the user explicitly does it, right? But for everything else, we can enforce it by default. Same we do for using inner HTML. And this is actually something that really happened, right? Because we used inner HTML in a bunch of our system privilege context, and someone managed this, found an entry point through our developer tools, injected some code, went through several layers, and all of a sudden we inner HTML'd it in system land, right? Luckily, this was reported by a bounty hunter, like one of the good guys, right? But if they can find it, probably the attackers can also find it. And the best way to eliminate that entire set of problems is by just removing inner HTML altogether, right? Then you don't have to care and worry so much about that attack vector. Additionally, what we are working currently, I mean, this is an ongoing process, right? And we are by far not done. There is way more work to do. I'm pretty sure we got out the low-hanging fruit, but there is more to do. At the moment, we're working on eliminating all of the JavaScript URIs, JavaScript colon URIs, which are very similar to eval, or in that sense, in terms of cross-site scripting, right? They are bad and we shouldn't use them, especially not in system privilege context. So the same thing which we did for eval and for inner HTML, we added an assertion that no one can add new occurrences of that insecure construct. And now we are burning and working through that allow list and eliminate all of those insecure occurrences. Additionally, we can think, or we are trying to work on eliminating assignments to .source, right? Like, why would system privilege context, like everything should be packaged within Firefox, right? Why would it ever need to assign a .source, like a frame.source or a script.source to HTTP and HTTPS and load something over the web, right? That is all classes of security vulnerabilities that we can just forbid entirely within content security. Whew, a lot of stuff, right? But I see people are still awake, which is very exciting because I'm super excited. And now, how does this all translate to me, right? What do I do now? I mean, this is great that Firefox is doing that, right? They have an entire content security team, but we don't have that at my company. What can I do? What can we do? What can we all do, right? And I think the good starting point is not rewriting code in the beginning. It is creating that different mindset that you need to basically look at your application from a security point of view. And this needs a lot of training, right? This doesn't come overnight, and you probably have to fail the hard way before you really can consider doing this. But I think it's crucial that we all try. Probably you are the wrong audience because you are here at the OWASP Day caring about security in the first place. But anyway, create a threat model of your system. This is a very good starting point. At some point, what we did is we just sat down on a couch, talk about random things, and just try to look at our system from a different angle, right? What is the threat model for our system? Who are the attackers? And what are their goals and capabilities? And this is a very funny exercise, I can tell you. And you are on the right track. When you go around to people and you hear things like that, why would anyone do that, right? Nobody. Like, seriously, nobody would ever do that. I never thought that anybody would do that. If you hear those things, you know, oh, we are definitely on the right track to changing something in our system. With that information, you can take yet another step back, and you do a security review of your system, right? You build a threat model for the application. And what is also an additional funny exercise, aus dem Nähkästchen geplaudert. Additional funny exercises, not only think about how people can attack the system, like your end users, but also people within the company, right? Is it a good practice that only one person has access to our code base? What if that person goes nuts overnight and eliminates everything? Now, in the newer times, this is not that big of a problem because we have distributed systems and our code base is not within the server in the closet in my own company, right? But if that was the case back in the days, never thought, or when I did security reviews, never thought about that. Well, what if there is a fire? Then all of our code base is just gone overnight, right? So those are things, what I like you to think about, not only the security threat from outside, but also from inside. The check-in procedure for your code, whatever guards you have in process. With that, I would like to summarize again our findings. And we have to support our developers. We should not put the burden on the developers. They should just use security. It should be built in, right? Like as a very good example, I came here by train. I don't know how a train works. I just want to board the train, come here, get off the train. I don't care about anything else, right? Someone else should take care of it. And when you think about that, when you apply the same model to security, I, as a web developer, mostly care about the number one goal here, getting an application out the door, right? It does something for a purpose. And we need a security team that basically supports our mission and makes sure we are all safe. With that, I would like to conclude my talk. Thank you so much for inviting and having me, and welcome to OWASP.
Vielen Dank. Achso, selbst wieder einschalten. Okay, jetzt funktioniert es wieder. Ja, vielen Dank, Christoph. Wir haben Zeit für eine Frage und ansonsten könnt ihr ihn später ja noch fragen in der Kaffeepause und er ist noch ein bisschen da. Hat jemand eine Frage, die er jetzt stellen möchte? Da hinten? Dann laufe ich mal ganz dahinter.
Hello, my name is Emma Remaike from Secure Code Warrior. Thanks for your talk, interesting, although I'm not technical. I'm curious, how do you see software writing workflow changing in the next 5 years?
This is a very loaded question, I guess. I don't think that it will change that much, actually, because we're also used, it takes time to establish new models, right? And 5 years is probably not a long enough time. If we talk about 10 years, I'm pretty sure that at some point our tools will catch up and better support us in terms of security, right? And what I mentioned earlier in my talk is retroactively adding security into a system is obviously very hard and very time-consuming. If we have better tooling in the beginning, then it could make our life a lot easier. But I think it will take more than 5 years to really get there.
Yeah, thank you very much. And you get a little present from Tsai as a speaker. So, because you want to say something? Good.
Yeah, I think maybe some of you know, so Karlsruhe is also famous for Karl Dreis, and Karl Dreis is famous for inventing the bicycle. And so we gifted every speaker a bicycle that fits into this tiny box, and with this bicycle you can cut pizza. And it has an OWASP engraving.